Hello guys and welcome to today's tutorial. Now in today's tutorial we're going to be looking at electrical installation, or you could call it wiring installation. Now we're going to be looking at a complete house wiring for just a 3 bedroom flat, a corridor and a washroom. So guys, stay tuned and make sure you watch this video to the end. You're going to learn a lot from this video. So yeah, as we all know, um you we take our electric sources from the power grid, the AC grid, the national grid. So we always have to meter these things. These things are being metered. It's either you have a prepaid meter or you have an analog meter, whichever one you have. But this currents that are being supplied to our houses are being metered by the PHCN or whatever actually organization is responsible for that. So in this video, I'm going to be starting off from actually getting the supply from the grid through a meter. So what you have there as a first box like stuff there you have is a meter. Then I have the distribution board very close to the meter. So this is actually a kind of setting for a pictorial setting for what is called a distribution board. Now, this is not how it looks like as a box, but this is what it contains inside of it. So, and then a few lightning bulbs and socket outlets for various rooms and, of course, at different levels. Yeah, of course, what you basically need in your washroom is lightning, so that's it, and the switch for it. Now, so some basic things you need to know is that when we're talking about lightning, it contains of both lights and fans. So when you hear lightning wiring in installations, in electrical installations, what it simply means is we're talking about the bulbs and what? And the fans to some extent. Now you could have other socket outlets wiring, but those ones are not really lightning, those ones are socket outlets wiring. So we're gonna be doing lightning wiring and socket wiring. So stay tuned. So this is the layout. I wanna have the supply from the national grid, like I said. So I have a neutral and a live wire from the national grid, from a pole. Yeah, a pole or some kind of station for it. So it goes into the meter. Now, this meter then supplies the output to the DB, and the DB then supplies the house, the rooms at various points, or the whole building at whatever level actually. So this is basically what happens. So you then take the output from the meter and insert it into a protective device. Now we all know what a circuit breaker does. It's a protective device that actually regulates the current flow and the voltage flow from the meter, so it doesn't actually go beyond the 220 volt or 240 volt, or perhaps the current doesn't really go beyond 400 amps, 100 amps, depending on the amount of load that we're going to be subjecting to these house. So based from the national grid. So I haven't connected the connected from the source to the protective device. Now what you want to start doing is start distributing this cable. So you connect your neutral to the neutral bar. This bar like stuff here is actually the neutral bar, where all the neutrals that are going to be distributed to the homes, to the rooms, are going to be connected to. And then you then connect and distribute your the live wire to also all of this is because these other small miniature breakers only take in the live cable. They do not actually take in the neutral cable. So all the neutral cables are going to be connected to the neutral bar, while the live cables are going to come directly into these breakers from the various rooms as they actually connect, as they travel actually to those various places. So what you have here is just simply the protective device, one which is controlling the voltage, regulating the voltage coming, and one which is actually regulating the current, the current flow. And the rest of this would actually be for the current rating. Now these miniature are of different amps. Now because this is basically lightning, or we use around 10 amps to 15 amps miniature breakers. Mostly you find them when you buy these distribution boards. So for 10 to 15 amps you could actually use that for lightning. From about 20 to 25 amps is what is mostly used for your socket outlets and so on. But lightning and fans, you could actually use 10 amps or 15 amps depending on the design of that distribution board you're using. So in that distribution board, you find that descriptions on different amps. Then you begin to make your distribution. Now you want to take one line of this miniature to one room. You want to dedicate each line of these circuit breakers, these miniature circuit breakers, to a particular room so that you can easily detect when there's a fault in a particular room. You know that this is what is happening, this line is what is faulty, so maybe you want to change it or something. So you take one line, as you can see, onto the first room. Now we're trying to connect it, so I've taken one line to that. Now I want to connect the socket outlet, so it's just simply connecting the live wire. I'm distributing the live wire now, so I'll just, for that of the socket is this first one. Yeah, so the socket outlet, but actually for the socket outlet what you use is usually a 2.5 mm. That is, the thickness of the wire should be 2.5 mm. Yeah, and if, yeah, 2.5 precisely. That's what you're going to use for the socket outlets. While for lightning, you use 1.5. However, for the sake of this, just for the sake of just kind of description here, I wouldn't be able to make variations for with that which is 1.5 and that which is 2.5. But you should know that when you're making your distribution, you're making your connections the for each of this lightning. You want to make sure that the lightning have a different circuit breaker and the socket outlet too has a different circuit breaker. So as you can see, I'm just connecting basically all I'm just pulling, I'm just extending the lines from one of the the miniature circuit breaker. But in reality, if you're going to have to do this, then you would dedicate one of the circuit breakers, whether 10 amps or 15 amps, to just the fans and the light and the bulbs, while the socket you're going to dedicate a different line for it. Now most likely some would want to have all the sockets connected to one circuit breaker, so that way you connect all the lightnings to one of it. So you want to do the same thing for the next room as well. You use one circuit breaker just as you've done in the first room. So all you keep doing is creating the same circuitry, the same kind of loop. Now, in a more realistic installation, if you're doing it real time, what you want to do is this. You, like I said, in the first room, you want to dedicate, make sure that all of that lightning are connected to one miniature circuit, just like you have in the first one, as in the first case. So you want to repeat the same thing in this one too. The socket outlets should have a dedicated miniature circuit. Like I said earlier, it's best to have all the sockets connected together in one loop, and they will have just one socket outlet. Like, since it's a three-bedroom flat, you want to connect all the sockets to one line, or perhaps say if there were four rooms per se, you want to connect two rooms to one of the miniature circuit breaker. Now, depending on the size of your distribution board. Now, some of them will be 16 lines. I mean, sorry, yeah, 16 lines if it's a large building, and there you'll have to begin to differentiate in terms of faces. But that's not where we're heading to now. What we're saying right now is that you want to be able to make sure that you dedicate a particular circuit breaker for a particular function. So you should have this circuit breaker to be maybe controlling, just to be connecting just the circuits. But in this case, I'm just basically connecting them without any differentiation for which cable is actually meant for your circuits, your lightning circuit or the socket circuits. So you just go about doing the same thing, repeating the same connections for each of the rooms, and dedicating one circuit breaker for each of the rooms. You connect your lightnings and you connect your fans and your bulbs, which are which comprise of the lightning circuit, and then you have the power circuit, and that's basically it, how you actually make this um, wiring connection. So, and then just as we have done for the rest of the rooms, we want to make dedicate the last circuit breaker there as well for the corridor and the washroom. So what you simply do is you actually uh, extend your live cables from the miniature and to the distribution to the socket, to the socket outlet there, and to various lightning in the socket there, and of course then you then actually make the extension to the wash room as well, as you can see. And this is basically the life circuitry. Now we begin to have the neutral running. Now for the neutral wires, all you simply do is actually just drop neutral wires to every point, the lightning, the fans, and then what have you. You just pick a line. Neutral wires are usually just shared between the resources. Just from the neutral bar, you take one bar and you distribute it to a particular room. Like, make sure you connect all the devices in that room that needs neutral, like the bulbs, the fans, and everything, and the socket outlets, just to a neutral bar. Now for the socket outlets, you want to give it a different neutral bar. But however, for the sake of description, like I said in this video, I would not be differentiating from uh, a, for that of the lightning away from aside to that of the socket actually. So I'm going to be using one line for each room. So the same neutral for the other room will be distributed, sorry, among all the appliances, as you can see. So basically that's how the the neutrals will be distributed from each neutral bar lines, and connected to the various uh, devices, the various electrical appliances that are within the bulbs, the switches, and everything that you have within that building. And of course, having connected the live and neutral cables, you want to create an earthen or ground earthing for the socket outlets for each of the socket outlets. So you're going to run your earthing cable through each socket outlets that are in all the various rooms. So this, as you can see, is the earthing cable, and usually it's a green color. So for that too, you want to use a 2.5 mm earthing cable, or depending on, or sometimes uh yeah, a 2.5 mm. It's most precisely um, recommendable for you to do that. So that's basically a full wiring of a complete home, and this house is ready for servicing. You want to test the circuitry and see, then make sure that everything is actually in order. This brings us to the end of this video. Please do not forget to hit the subscription button and stay tuned for when next I post a new video.